control flow of query process in Lucene. Here you can see the control flow of query process with linear scan. Linear scan is a simple process of sequentially going through each line of the system and checking for the parameter, that is condition given in the query. This is precisely how Unix grep command works, and it also more fairly well with the wildcards and regular expressions. If the size of data set being search size is not too large and the hardware being used reasonably powerful, linear search is the simplest way. However, linear search start showing the performance degradations beyond a medium size document. The world around us is too experiencing an information explosion. In fact, the amount of data that needs to process to extract information has quadrupled over at least 10 years, thanks to the advent of connected world, handheld devices and IoT. Linear search cannot scale to meet those needs, so we need something more sophisticated and performant that can handle massive dataset while still providing relevant results at reasonable speed. Linear searches also limit what kind of queries can be answered. For example, there is no way to define query that seeks close matches of the given pattern. Suppose an instance that we search for document with the words flower and sunshine within proximity of 3 words in a document. Doing so with linear search is impossible. Also, there is no notion of ranked result. That is, given a query, a result is either a match or not for a linear scan. If we want some sort of ranking, we cannot use this linear scan. The inverted index is a data structure used to store data in an inverted manner, that the terms are mapped to a document in which the terms appear. Any unique term appearing in any document is made a part of the inverted index. To create an inverted index, the fields within the document are first split and tokenized. A shorted list of all unique terms are created, and the documents that contain corresponding terms are populated. While being fast for single term query, inverted indexes are also answer an important class of questions, similarity queries. This figure shows the typical way a query is processed in IR systems, information retrieval systems. A query comes in and is passed and is split into individual tokens. Token is an independent term having its own semantics in a query. For example, consider the following query: find all people who drove to college yesterday. In this scenario, tokenizing the query will lead to the independent terms such as drove, college yesterday, and to. Stop list. Stop list consists of words that are used in the associated language to form the structure of sentences, but are not necessarily useful for semantics matching and searching. For example, in sentence Alex went to London, we see that the word to is a stop word because that helps form a structure of the query. However, it cannot necessarily contribute anything to semantic assessment of the potential document match, and so it should not be considered on the same lines. Stop words are filtered out before further processing to help limit the number of tokens in the index to ones that can contribute to the relevant document. Of course, later on we might discover some of the semantically able words are not useful in matching a relevant document, but that is done stage by stage. Stemming. Queries can contain words in the different forms with different tenses, spelling, and associated grammatical semantics. For example, drive, drive-in, drives are all based on the same word but differ in their structure. However, for semantics matching, the actual structure of the word is of little value. What really matters is the root word, which will contribute to calculate the overall relevance of a document to the query. Another advantage of discounting different structure of the same word is to allow the one to match the remaining. For example, query containing the word drive should match document containing the word driving. This increases the recall of the query result. Recall is defined by a breadth of the return result, that is how many documents match a given query. Unlike the relational database, IR systems can answer queries with the semantic element with them. That is, any document can match the given query. The trick is to identify most relevant ones and eliminate the unnecessary noise. Recall is the width of a document and return result. However, too high a recall and return result will have lower correctness. Too low a recall and return results are very small in size. Most IR systems struggle with this trade-off. Stemming is the process of reducing words to their base word and removing structural differences between words that originate from the same root. However, stemming can be crude in the operations. For example, stemming can employ a crude heuristic to remove parts of the word which can sometimes lead to weird semantic outputs. While this is efficient and works most of the time, the more sophisticated way to deal with this requirement is the art of lemmatization, rewriting words using a given vocabulary and depending on morphological analysis of the tokens of the query. Lemmatization is beyond the scope of current discussion. To avoid linear search, you can index the set of document in advance and use special queries to get the right set of results. Consider, for example, set of document with the range of word present. Let's use a group of related books shown. Books database in action world of Lucene introduction to information retrieval. Let us assume that we have to serve queries across all three of these books. Doing so requires what we index data across all three books so that we can efficient in query operations. Note that there are multiple ways to do same thing. We can create a separate index per book or index all three books in the same index. Note that these books will have the same key terms in common. For example, except search to be present across all three of the text. Similarly, bytes is another term that can repeat across all three texts. The naive indexing technique is to maintain independent metadata about each of the document, effectively discarding the common terms present. This method is a waste of space and is inefficient for serving queries that seek matches across all text. To implement inverted indexes, you first need to understand concept of term and the term document incident. So a term document incident matrix. Here you can see queries connected to query tokens via pass query. Query tokens tokens are connected to stop list via filtering. Stop list is connected to stemming. Stemming is connected to index, and index is connected to retrieved. Index is connected to Boolean or similarly query via retrieve relevant document set, and Boolean or similarly query is connected to ranking docs via ranking. Now this is the end of my presentation. Thank you very much for watching it.